The James Webb Space Telescope has reached a major milestone. The foremost observatory in deep space is now in focus, with results to show it. There have been 17 years of building, 8 launch delays, and 5 months of alignments in the 25 years since the James Webb Space Telescope was first conceived. Now things are finally heating up. Using a completely aligned space telescope, the European Space Agency has unveiled 10 jaw-dropping new high-definition images of stars taken by the Webb Telescope, showing it is capable of taking razor-sharp images of the universe with precision even beyond the wildest hopes of its designers. How did the new photos come to be? Is the NASA James Webb Space Telescope aiming at any specific stars or planets? What's the next thing on the list to be found? Let's find out in this video. With a large 6.5-meter primary mirror capable of detecting the dim light of faraway stars and galaxies, the James Webb Space Telescope is the most ambitious and sophisticated space telescope ever built. Its main purpose is to detect infrared light emitted by distant stars, planets, and gas clouds. With longer wavelength coverage and considerably enhanced sensitivity, it will complement and extend the discoveries made by the Hubble Space Telescope. James Webb is now watching from a distance of around 1 million miles from Earth, but it will be able to see the first stars and galaxies in their infancy. Researchers at NASA have been working non-stop since the spacecraft was launched on Christmas Day of last year to synchronize its 18 gold-colored mirror segments. As a result of its size, Webb's mirror array had to be folded up in order to fit inside the rocket for deployment. After the 7th and final round of testing, NASA and the European Space Agency confirmed that all of the Space Observatory's imaging sensors passed with flying colors. NASA released a sequence of images displaying Webb's full field of view in deep space to commemorate the completion of the alignment of the telescope's mirrors, which are used to catch light from distant and ancient galaxies. Webb's 3 imaging equipment, as well as its spectrograph and guiding sensor, are represented in this image. In the Large Magellanic Cloud, which is some 158,000 light-years away from our own Milky Way, the photos reveal a vast field of stars. It would be the greatest satellite galaxy in the universe if it were to circle our own. It's possible that it's just passing through, or is gradually integrating into our galaxy, but it's impossible to be too certain about these things. However, each of the James Webb Space Telescope science equipment renders a dense field of hundreds of thousands of stars in the narrowly focused photos. Each of Webb's instruments is seen here in relation to the telescope's focal plane, with each aiming at a little different portion of the sky than the other. Though photos from space telescopes are sometimes used to recreate color the way people see it, they are also used to highlight specific features. The scarlet color scheme was used by NASA engineers to emphasize contrast. According to a NASA report on the milestone achievement, the telescope's image resolution is as good as it can be for its size. From now on, the major mirror parts will only need to be adjusted in tiny steps on a regular basis. Since its first image in February, which showed 18 different golden fuzzy blobs representing one star, the telescope has gone a long way. NASA guaranteed that further instrument calibration would improve the equipment's ability to make a clear image. That promise was fulfilled by mid-March with a new snapshot of a star in Ursa Major with enormous spikes of burning red was released. During an unrelated briefing, NASA's assistant administrator and former astronaut Bob Cabana said, "Just look at that aligned Webb photo on your phone. All you see is that star. But if you spread it out with your fingers, there are galaxies behind that star that have never been seen before. And that's going to be absolutely amazing." The James Webb Telescope's infrared photos, while lacking some of Hubble's panache, will aid scientists in their study of one of our nearest stellar neighbors. The LMC image was captured with the following instruments. The first is the near-infrared camera, which is Webb's primary set of eyes that sees infrared wavelengths slightly beyond what our eyes can see. It also has a coronagraph, which can block off light from stars so that planets can be found directly. There is also the mid-infrared instrument, which can detect fainter astronomical objects like distant galaxies or comets on the outside of our solar system at wavelengths much beyond those of NIRCam. In order to perform these measurements, MIRI had to cool down to just above absolute zero in order to avoid affecting its sensitivity by the heat from the instruments that were being used. The third is the near-infrared imager and slitless spectrograph, which is an imager that works with the fine guidance sensor to break down the light of seen objects and establish their composition. This will help with things like exoplanet atmospheres, which could tell if some Earth-sized worlds are genuinely Earth-like or a little more poisonous, like Venus, or nearly airless, like Mercury, or something altogether different. For Webb to accurately point at an object, it relies on the fine guidance sensor. FGS and NIRISS work together as a single instrument, with NIRISS serving as the primary eyes despite FGS's poor imaging capabilities. The last one is near-infrared spectrograph. This is more of a raw scientific device that breaks down light into precise wavelengths, despite having an imager for guidance. This will aid Webb scientists in delving into the early universe and discovering what was going on at a time when there were few heavy elements. Each instrument is a complicated collection of detectors with lenses, masks, filters, and other specialized equipment to aid in science. Although NIRCam and NIRSpec will be doing a lot of the cutting-edge science, the MIRI camera will most likely provide us with incredible wide-field astrophotography images than the Hubble. The image from MIRI, for example, stands out in this first set of images released. You can see emissions from interstellar clouds as well as starlight if you look closely. Calibration photos from the observatory's fine guidance sensor were also made public as a bonus. It actually isn't there to undertake scientific imaging because it utilizes two sensors to precisely orient the observatory. NASA also released a video to celebrate the alignment with the ESA's image. These amazing test images from a successfully aligned telescope show what people from all over the world can accomplish when they have a bold, scientific vision to explore the universe, said Lee Feinberg, Webb Optical Telescope Element Manager at NASA's Goddard Space Flight Center. Also, Scott Acton, a JWST wavefront sensing and control scientist, shared his thoughts on the project's impact on him. With the completion of telescope alignment and half a lifetime's worth of effort, my role on the James Webb Space Telescope mission has come to an end. These images have profoundly changed the way I see the universe. We are surrounded by a symphony of creation. There are galaxies everywhere. It is my hope that everyone in the world can see them, Acton said. So where does the $10 billion telescope go from here? As part of a collaboration between NASA, the European Space Agency, and the Canadian Space Agency, the James Webb Telescope will observe some of the universe's oldest and dimmer light. The massive telescope will focus on the first 300 million years after the Big Bang, when many of the earliest stars and galaxies formed. Scientists will also use it to gaze into the atmospheres of exoplanets, which are worlds outside our solar system. Water and methane discoveries, for example, could signify the presence of life or the presence of biological activity. Our understanding of the universe is expected to enter a golden era because of the telescope's ability to capture images of distant galaxies that have never been seen before. The JWST crew has unanimously agreed that the telescope's alignment is complete after discovering that its optical performance is even better than its most optimistic expectations. The final phases, known as science instrument commissioning, have been started by the team. The telescope will be ready to conduct revolutionary research in roughly 2 months once the process is completed. Part of that procedure will entail pointing the telescope at different parts of the sky where the total amount of solar energy reaching the observatory varies to ensure that the observatory's temperature remains constant while changing targets. The mirrors will also be examined on a regular basis to ensure that they remain aligned. NASA authorities have announced that a collection of jaw-dropping images and related scientific data will be distributed in full resolution in June. To date, no specific celestial targets have been revealed by the agency. JWST will be able to see back in time, perhaps to 100 million years after the Big Bang, when it is completely operational. Until then, science is getting more interesting. Who knows what the Webb Telescope will uncover about our universe by the end of summer? Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more amazing content.